And just in terms of getting adoption, what's the primary challenge at this point? Is it the maturity of the technology? Is it where the customers are in terms of creating the products or designing the products to use new embedded memories? Is it cost? I mean, if you had to choose kind of one roadblock.
It's all the above, right? That's a new technology coming to market, right? So number one is adoption. Adoption goes with accepting big fab, reducing the costs. It takes time, but the key attribute is that there is a key value add adds, and the number of applications, like I was mentioning, there are certain applications where people are using multiple NOR flash because the write speed is limited, right? You need high speed. So somewhere instead of 3 or 4, you can use one, gets a cost advantage, get adoption. So it's adoption and time.
And I'm just going to add that the technology is well understood. The physics, it's easily controllable. So we are not technology limited. We're limited by learning to manufacture this in high volume, and then also customer adoption. We're dealing with customers that are conservative and want to make sure that you don't lose their data. And so to accept a new technology, they like the attributes, but they need to get comfortable with the reliability of it.
Just to follow up on that, I think it is really kind of all the above, Matt. But there are a couple of things that emerge. One is that the companies that are shipping MRAM today or sampling it, are not the traditional large corporation semiconductor memory suppliers that people get very comfortable with in terms of driving costs down and quantity and supply. So we've had a lot of work to do to convince customers that a company like Everspin can deliver, and partnering with world-class foundries has really helped us in that regard. The second would be that from an ecosystem infrastructure standpoint, I did mention that there are some differences from a controller design perspective to take full advantage of MRAM, or at least how we instantiate it. And so everybody asks us, well, can I use an Intel chipset with your memory, your DDR3 memory? And the answer today is no, you can't. But there are a lot of alternatives to that, and if you want to secure DDR3 controller IP from any number of the FPGA or ASIC IP providers, it's all available there. So it's coming, but it's been a little bit of an uphill battle, to get to that point. But we're starting to see the acceptance.
And sorry, I lied. I'm going to ask one more question. So crosspoint, obviously that's been a big change since we were here last year. I guess, how do you see crosspoint influencing your business model, or does it? Does it help or hurt your attempt to bring these emerging technologies to market? And then because Intel won't tell us what crosspoint is, if anyone wants to hazard a guess. We heard phase change earlier.
Didn't the Micron co-CEO in Lehigh kind of let that leak here in the last week? I seem to have heard or read something like that. Okay, so I'll take your question. First, I'll talk to everyone that's here from a company not named Intel. If you love what 3D Crosspoint does architecture-wise, and you really love handing Intel a lot of your money, then please buy 3D Crosspoint. But if you love what 3D Crosspoint does architecturally and want to save some of that money for yourself and are interested in alternatives, then let's talk about that. Because I think there are alternate approaches that give you the same architectural advantages. So again, Intel and Micron have done something tremendous. It took 15 plus years of incubating the technology, much as MRAM has incubated for that time. And so the architectural changes are ones that many of you would like to adopt. But let's think about the economics of it, and we think embedded MRAM is a way of giving you a fast slice of non-volatile memory in that complex processor, which will give you some key advances.
I think from technology point of view, that's exciting news. Like I said, we believe you have the selector and the memory in that case is phase change, right? So So you're limited by how fast your memory can, write, set, and reset, right? So I think that's exciting. We believe in future you'll see MTJ going in there. And that, can you imagine if you have MTJ putting there, switching at 10, 20 nanoseconds, and then you're talking about capacities of hundreds of gigabyte of non-volatile, high-speed memory, and that will really change the system architecture. Many changes will come. So it's, in the beginning, I don't think it's in the space we are working on. It's still it'll be more storage class memory. So it's a good news in a way.
I would just add that for the market space that we're trying to address from an Everspin perspective, that 3D crosspoint really is kind of opening some doors for us because of the fact that you have this growing groundswell of persistent memory software and what it's going to mean to the system and how to use it. So that I think will help us. But the difference here being that when you really get down to very high endurance and very low write latency requirements, there's a distinction between spin torque MRAM and 3D crosspoint. So there's still an opportunity for both to do very well.
And so I think we have time for one or two questions in the front.
Yeah, question for Joe. I'm a little confused. It sounds like your relationship with Global Foundries is one where you're providing IP to them that their customers can incorporate in ASICs or custom chips. But you also are it sounds like you're selling discrete chips to these server appliance people. So which is your business model, or are you doing both?
Well, actually, you're not confused. You've got it right. We're doing both. In fact, that's what the slide stated, actually, that we will be selling Everspin branded standalone persistent DRAM made with STMRAM technology, manufactured at Global. And Global will also use the IP to do the embedded work. And if a customer is actually looking for embedded capability, we're going to steer them towards Global.
One more question, Ed.
I want to thank you. You gentlemen always do such a good job. Okay, so I think the audience appreciates it very much. I agree with your technology in performance, in reliability, and all those great things. But I'm questioning density. The cell that you're showing, okay, uses a CMOS transistor. So is it true that STT-RAM and a few other non-volatile memory technologies will always be dependent on the density of the CMOS transistor unless I can create a multi-bit stack?
So I think that, and did everyone hear the question? There was a comment on utilizing the transistor to drive the MTJ stack. For the foreseeable future, certainly for embedded memory, it's tied 1T, 1 MTJ, and the cell size there is going to be measured in low tens of F squared. So, but for an embedded market, that's okay. I think for a standalone market, it's a bit more challenging.
Right. So, Ed, it's the transistor size is basically determined by what's the right current, right? So that goes by what the MTJ you design, number one. Number two, what kind of design rule you have available, whether you're using memory fab or using logic fab. So logic fabs, your design rules are typically, much more relaxed, not as such memory. So I would say it's more. That's another thing which determines. But end of the day, if you look at the cost point of view, there are three factors, right? How small a die you make it, what is your test cost in there, and other packaging, like how much efficiency you have, memory efficiency. So I think it's not only the cell size you got to look at, how much logic, there's no charge pump required like Flash has. So the memory itself is much more efficient, and the test cost is much lower, right? Because faster memory. So the cost point of view, you have to look at the whole thing in totality. The size is not quite there because it's a new technology. We are trying to get there. So it's a matter of time.
And so I just started. We have time for one more question in front of the projector or behind the projector.
Storage class memory is like an oxymoron because memory doesn't have redundancy. Storage is redundant. How do you get redundancy at memory speeds.
So I think Intel would love to tell us exactly how that's done, and we'd like to see how their memory controller is going to operate here in the future. So I have no comment to answer your question. By the way, for the guys in the room that are from Intel Corporation, we would be more than happy when you want to outsource your manufacturing. We'd be more than happy to make those wafers for you.
Thank you, Matt, and thank you to the panelists. We're now up to the lunch hour. In 20 minutes, at 20 past, Edward Sharp from PMC Sierra, and I'll have a little story on that, is going to be coming up and will be our next keynote speaker. We're going to start at 20 minutes after the hour and run through this hour lunch break. So those of you who get your food quickly will see more of Edward's keynote. So those of you in the back of the room have an advantage getting to the food line.